Hi, I'm Rob. I'm going to talk to you about some type checking tools, and that means nothing to you right now, but it might mean something to you a little bit later on. But basically, ways of sort of checking your code and some tools to do it, and basically the entire approach. And we're going to use, Flow and TypeScript as specific examples. So also, can people hear me just before? Yep, I get going. Cool, awesome. Anyway, so this talk is pretty much about preventing mistakes. Haha, yeah, you see the visual gag? I'm so hilarious. Moving right along. Mistakes. There are a few different kinds of mistakes, or a couple of different kinds, and I'm just going to generally classify them and, you see if you agree with me or not. But there's kind of like more like immediate mistakes. Mistakes like screw-ups that you find out about immediately, know that you've screwed up. It's incredibly obvious. In terms of code, it'd be code that as soon as you run, explodes in your face. You get immediate feedback that you did something really wrong and you should do it better next time. So this is just, it's a pretend example, but basically I've got a function and I've got an object thing at the top, and down the bottom I'm using some part of this object, and I'm kind of using it wrong. This function is like 20 lines long, and I've just lost track. I've changed something over time. So config has a property sassc, and it's actually like a string or something. And then down the bottom, I'm using it as if it had like a bin path thing. Now that ain't gonna work. That's an undefined. You're gonna get okay, well, I need to correct the example, but let's just pretend we're going one level deep. I just realized now it's not gonna explode unless you add another like a dot sort of thing. Whatever. Okay, let's pretend it exploded and move on. God, I'm fucking nervous. My apologies. I'm not usually this nervous of meetups. All right, so we've got a different kind of thing that's going to explode in our face. So the first one would, let's pretend I wrote it correctly, would have exploded regardless. It was like a building that hadn't been built properly. It wouldn't actually stand up correctly, just fall over as soon as you try and use it. This might break or it might not break, depending what you give it. If, for example, you gave it a user and the user didn't have a title, this would explode with a, method... forgotten the error. Basically, the thing that happens when you call the function on undefined and it has a big sad. Yeah? Can someone call out the error? Someone knows this? Someone has seen this 20 times in the last, 6 hours or something? No? Right, fine, whatever. Yeah, okay. Sorry. Let's try that.
Can't call to uppercase from undefined or something like that?
Yeah, something like that. Cool, all right. So, but suffice to say, the thing explodes in your face and, it's not great. But fortunately, it's contained. It's basically within the one file, within one function, within one module, and it's basically, structurally unsound. It's going to explode right there. It's more like an immediate mistake, some screw up that isn't going to affect too much. Like as soon as you touch it, boom. So there's kind of another sort of a group of mistakes you could think about. I'm going to call them delayed or deferred or whatever, or something else has the problem now, sorry, or soz lol. I'm apparently a millennial, so I can write things like this even though I'm 30 plus and have a beard. I've got some more code example. I'm pretty sure this one's going to break because I don't have much in there. But bin path sometimes could return undefined. If that if condition falls out and you get to the else, well, there's no else. The bin path is going to return undefined as a value. It's not going to explode. It's just going to return undefined, which is not useful to us. Where bin path is just a path to a file, a path to a directory on disk or something. And we're intending it for it to always be like a path to a directory on disk. Undefined is not what we really meant here. So we go along and use it in the second file, and we go to use it, we get our bin path, it comes back undefined. We don't know about this yet. We stick sassc on the end, we're about to go run it, we go run the thing, and kaboom. So it's not an immediate mistake. The original file, the source of the problem, didn't feel any of the effects. It was when you tried to use it that the thing exploded. The mistake basically kind of propagated. So here we're talking about two different files. We've got the origin and then where it actually exploded. But, there could be multiple places we're using this function. Yeah, so you write a function and it works the first time, or it works for a while, and then you change it and then suddenly a whole bunch of things screw up. Like a whole bunch of things fail as a result of you changing it badly. It in itself never sort of fails or throws an exception or whatever. It just starts returning the wrong thing, and suddenly you're filling across the entire code base. And it may be a case of you're directly using the result here, or you're passing it along to something else which then explodes, or you're passing along to a library. Who here has debugged like, 4 or 5 levels of stuff being passed along that's always goddamn wrong? Yeah, cool, all right. I saw like at least 10 hands. I'm going to pretend more of you put up the hands, but yeah. I feel that frustration. I hate that feeling, and I hate that it happens. I don't really like for it to stop. So it could be things like undefined, or it could be just like other things you don't expect, like not a number is one of those things that propagates around, or it could be just any value you're not expecting. For example, something that doesn't have the right property on it, or some string that is not actually quite correct, or something that is used. Little Bobby tables, is able to be used. It can be used in a different context, and which is wrong. Like it isn't inherently wrong, but it can end up in the space where it becomes wrong. So, I'm going to posit. And if you disagree with me, I'm sorry. You're going to have to hold it in because the rest of my talk is based on this. But I posit that basically you want to try and get more to the immediate end of this spectrum rather than delayed. You want to find out if you screwed up sooner than later. Vaguely sort of agreement, yeah? Cool. Yeah, all right. Everyone's nodding, great. And so we've got ways we can try and do this, where, beyond the write in such a way that it explodes immediately, whatever. But we've got testing, where we pair each chunk of code with a chunk of test. And so we run the tests, and as part of the entire sort of build process fails. It basically you try and make it fail, just when you're trying to keep the test and the code sort of localized, so you can track where things are going wrong. You write a test for a particular function, and you know exactly like this thing breaks, therefore the other thing is broken. Yeah. Same with linting. Linting is even quicker. You find out much more quickly. For example, you find out that, for example, that. Say, semicolons, whatever, but no, I'm talking about stuff like, double equals versus triple equals, or there's another example, but basically, or using eval or something like that. Basically stuff that could be really unsafe, and you want immediately feedback that no, that's going to cause problems. You want quick, immediate, localized feedback on the code that you're working on. So, at the beginning of this talk mentioned something called Flow and TypeScript. And so they're 2 different tools that are basically sort of really good linters. They're really smart linters. And we can use them in order to help check our code in a similar way to linters can. Both, so you can focus on, so you can constrain where your problems are. Like basically don't let them escape out of that little bubble, trying to catch them sooner than later, basically. And so both of these things are sort of JavaScript plus some bits. So both work on JavaScript directly. They're both tools that work on JavaScript. However, they add their own sort of bits of language to let you say more to the computer. Because sometimes it's not smart enough to figure out this stuff itself, and so it needs a little bit of help, or sometimes you want to intentionally tell it to work in a certain way. I'm going to cover that in a moment, but basically it's a separate language that looks mostly like, both of them are separate languages that look mostly like JavaScript and turn into JavaScript and run as JavaScript. Yeah. I hope that's going to make more sense in a moment. So we've got an example of JavaScript. It's also a valid Flow example. If you add a comment at the top, I'll get back to that. Or if it's a valid TypeScript example. And so we have the option of, stating our intent, writing down, telling the computer what we intended for this to do. We expected hello to get a string, and we expect it to return out a string. And then, the result of calling hello is going to also be a string. We can state all this stuff and tell the computer pedantically over and over, but most of the time, or a great chunk of the time, we don't have to. It can figure out a bunch of this stuff itself. It can infer things. So I'm going to focus on Flow for the remainder of this talk because A, I know it better, and B, both it and TypeScript 2 specifically have basically reached parity in terms of what they can do with some, outside of some little subtle approach stuff, which isn't going to matter basically for the context of this talk. So here's an example of a Flow project we're going to get set up. It's just got a source directory, and we're using Babel already because we're already doing some ES 2015 because we also hate ourselves. Anyway, so I'm running the program here to show it works, and then I'm going to install Flow and then Flow Watch. Flow bin is like Flow itself, and then Flow Watch is a tool that'll just help run things in the background. And we also need to tell Babel about the sort of the Flow syntax stuff I just told you about. So there's a preset that will let you go and strip out the types before you then compile into runnable JavaScript. But I'm just adding Flow here so I can get it all going. And then It's still working as before. Cool. So now I'm going to start the flow project in itself, and you do this once per project. So you initialize it, and then we're going to kick off a server, and it runs in the background, so it just stays running to, to able to be checked quicker, and then, it gives you a result. And if you hit flow again, as I said, it gives you the result pretty much immediately, because it's sitting in the back waiting for you to change files, doing sort of recompilation in the background. Yep. So, wow, there were no errors. Woo! Doing a great job. We haven't actually got around to using the tool yet, but so they're both of them intended to use on projects that have not been, they're both set up to sort of, in a way, sort of flow is very much like you start at a file and work outwards and work to like spread gradually. It takes over the entire code base. TypeScript is something similar in how it does it, but anyway. The idea is you start with nothing and then you gradually introduce flow or whatever, or you can start an entire new project and use flow and TypeScript for the entire thing. Flow or TypeScript, depending which you pick. So anyway, here's actually using a bit of flow. So we're going to open one of those files. It's incredibly simple. We've just got this double it thing, which just takes a number, doubles it, returns a result. Whoa, it's incredibly simple just for the sake of illustration. And then we're actually going to use double it and pass it a number. So I'm going to kick off flow watch in the side and just, so I can just watch for any errors and stuff. So every file needs to be tagged with this @flow. I intend for this file to be checked by flow. So chuck the comment on the top, save, cool. It all works so far, and that's great. So let's break it. So 2 is a number, but let's try a string and see what happens. And well, it fails. Basically, num in this case is being used with multiplication, and multiplication doesn't work on strings, or rather, multiplication has been defined so that it only works on numbers. We've intentionally said this is a number-only thing. We never want not a number anyway, so yeah. So what it does is, where we've used it, it gets deep into, the error shows up inside double it, because that's where the first case we tried to use the string and multiply it, and so that's where the error message is there. But we can state our intentions again. We can do, like with the string example, we can say that we always want it to take a number. Come on, Rob, hurry up. Okay, cool. So we save it, and now it's saying, oh, it was how you're calling it that's wrong. It would double it in itself wasn't wrong. It's you're holding double it wrong. So in this case, you're giving it a string where it really isn't, where it really doesn't expect to take a string. So we basically stated our intentions to the computer so they can check things more effectively, but it was still checking it anyway. It was still checking if it was internally consistent. It's just a case of we tell the computer more information and it can give it more useful information back to us. So hopefully that wasn't too bad in terms of extra stuff you have to do in order to basically use flow after you set up the project. You set up the project, you add the occasional type annotation or whatever inside files, So there's often the impression that static typing is this sort of experience. If anyone came into this expecting basically Java or C#, or I've done both at uni, I did like a PHP and I did Java and C# and stuff at uni, and I really wasn't crash hot, and then in PHP and JavaScript and Ruby and for the longest time. But basically, much in the same way that if I said that JavaScript, PHP, Python and Ruby are all the same language, everyone would have a shit fit in here. Oh, sorry, I shouldn't have said. I'll keep it PG. People might have a bit of a sad about it in the same way that static typing is basically a family of tools. So it could be Java or C#. We do have to, like Java particularly, you have to keep repeating yourself over and over. Or it might be other things like Flow and TypeScript, or stuff like Haskell, or stuff like Scala. I'm not a Scala dev. I just saw the sign. It's right there. Anyway, but they're all very different tools. Like dynamic languages, like the ones I mentioned before, are their own family, and static typing is another sort of family. And this is like a static typing bolt-on. And speaking of static typing, I haven't even defined the term left. So let's talk about types. And so types are kind of like grab bags of stuff, grab bags of values. We've got a type and we've got a bunch of values that the term people use is like inhabiting a type. But basically we've got a bunch of values and we chuck a name on it called Boolean. So in the case of Boolean, we've got true and false, and that's it. No undefined, no null, no numbers, no strings, just true or false. And that's the entirety of the Boolean type. It has two members, true and false, and done. So similar deal with string. String could be a blank number. Blank string, sorry. It could be hello. It could be two or two. It could be the entire works of William Shakespeare, or this guy who made a speech one time. We've got numbers, where numbers are again like the space of all the possible numbers. This is the IEEE 754 float, if that means anything to you. But basically, the number type is all the numbers you're used to seeing in JavaScript. These aren't universal declarations of what types are. This is how Flow and TypeScript have chosen to define what their type buckets are. These arbitrary groups of what these values are. So they decide to group like numbers as all the things, including the decimal points and nan and infinity. Or they've decided to say strings are all the JavaScript string types. That it's arbitrary bucketing, but we don't care. So this is these are again like Flow examples, Flow and TypeScript examples. But I'm going to switch over to live coding and show you some of the rest. So I'm going to give this microphone back to you because I don't have 3 hands. All right. So can people hear me? All right. I'm going to have to do this a bit. Also, can people see the size of the text? I can bump up this up and down thanks to the magic of live coding. Is this large enough, or should I bump it up? Sorry, larger? And bigger? Is this bigger? Oh, sorry. Technically correct, the best kind of correct. Sorry, the people at the back, do you want it made larger?
That's fine.
Okay. Yep. Fortunately, there's literally one bit of green on the entire screen. It's on the right. You don't actually need to read it, so ignore it. So types, the ones I just showed you. We've got Boolean, true and false. And again, like this is flow checked, so I can. Whoa! What the? I love live coding. I pressed the wrong button. Anyway, so I'm going to ask Flow, is undefined a Boolean? No. Is 7 a Boolean? No. It's absolutely not a true. The string is absolutely not a Boolean. And all I've got is the assertion of the type here. This is basically like a double entry bookkeeping. Like I've got, for example, I'm saying that no is a Boolean, and then I give it the Boolean. And then, so it's a case of like Boolean, the assertion that I've got it, and undefined is the value, and they don't line up, and it has a sad on the right-hand side here. But we can easily do this will happily let it pass because it doesn't care. We haven't like told it what the type of the variable is. I haven't said that look ma no type is a Boolean, but if we use it like a Boolean and then we try and use it, then it'll be correct. And if we don't use it like a Boolean, we try and add a number to it, then it'll explode. So you don't have to annotate all this stuff. I'm just putting this for the sake of example. Oops. That stuff down the bottom is not relevant. And is in fact, it's running, but it's not. I should have just deleted it. Anyway, so we've got strings, as I said before, and again, 7 in fact is not a string. We've got the numbers, and again, there's none of this sort of you write 9 in a string and it suddenly turns into a number stuff. It's a string or it's a number. You don't automatically jump back and forth because that just creates all sorts of possibilities of stuff going wrong. So null is entirely its own type. Null is a type, and the only valid value for null is null. Not undefined, not string, not everything, it's just null. Same deal with, I've explicitly called out here, null is not undefined. Woo. There's a second type. Unfortunately, they called it void for some reason I have not figured out, but it's void the undefined type, and which has a value undefined. It's the same deal. There's literally one thing. So it basically means you can't mix up this string stuff with the undefined stuff. You can't get, I want a string. You can't say, I want a string, and then suddenly show up with undefined and have it percolate through the rest of the program, like I said earlier in the present. So, yeah. And some more complex ones, like this one here is, you can see the list down the bottom. It's an array of numbers. And I could specifically say, I could give it some array with numbers, and it'll just, yep, that's cool. You've got more complicated stuff like an object here, which is just saying that's like the type of this. It's got an ID with a number attached to it and a name attached to a string. And again, it's just inferring this. It's just figuring out, just reading the definitions of this stuff to figure out what the type of all of them are. You've got functions which are in themselves their own type. I'm just going to focus on the second one. Add1 is a function that has a number. It takes a number and returns a number. But the incel, you can annotate things as this is a function type. I'm not going to dig into it, just saying it's possible in case you get some of this. And finally, we have one kind of special type, and that's called the any type. And the any type is like this. If ever you get stuck, I hate the any type, but it's there if you really need to use it. It's basically used as an escape hatch, just like to say things to it's like, oh, screw it, whatever. Just trust me, computer, I got this right. Inevitably, when you do screw it up, the computer will laugh at you, but you know, you told it to go ahead anyway. Okay, I'm just going to, yep, cool. So, yeah. So I'm briefly going to blitz through the problems that some of it can catch, because you've seen a little bit earlier in the preso, but this is, for example, this is an example of a typo. I've got const user and it's got a field name. Okay, usually there's a little red X that shows up on this line here. Editor integration, oh God. Anyway, but suffice to say, it's having a whinge about the thing on the right-hand side, this namey thing. It's because I type it, and if I fix it, it's fine. It's just making sure that I got it. This user thing has a structure to it, has a type. Even if I don't actually specifically write anything down, it's got this. It's got a field called an ID, and it's a number, and it's got a name with a string, whatever. And so it's just checking how I'm using it with how I've defined it to make sure they line up. It's just doing some internal consistency stuff. And you know, it can be more complicated. For example, it says you've got an array in the field or whatever. I've again typoed a thing, and this would have exploded at runtime because, it would just like have like a blank string chuck in the middle of it, and we don't really want that result. So again, Flow is checking it and telling us that we screwed up in that particular case. I fixed the typo, you know, and it's all happy. Okay, so we've got something that works so far. We've got a function that is like a summary of a user. The result of this is just going to be, so Dr. Katie Potts with an ID 1234 and Doctor is the title. And that works fine. It doesn't work though as soon as we try and give it Sam. Katie has an ID, a title, and a name, and Sam has an ID and a name. It's not lining up. Something's wrong here. So we've got the ability to actually sort of state our intention here. We might, for example, say that we've got a type of user, and it's just an ID is a number, a title is a string, and a name is a string. We've got the capability here to say that we intend for Katie to be a user, or hell, I can leave Katie as it is and just say, I want to only take a user. This function will only work if you give me a valid user. And so, we've got, sorry. Yeah, so we're passing the user into summary, and it's not lining up. Again, Sam is wrong in some way. So what we can do though is, again, we can say maybe that not everyone actually has a title. So we'll just make it an optional field. So it then switches to telling us that, okay, cool, it's fine. Maybe the title isn't there. You've got an ID and maybe a title and a name. But your function isn't actually respecting that. The function is assuming it's always there. The function summary, which takes a user, assumes that user.title is always a thing I can call to uppercase on. And it's like, no, you screwed that one up. So it makes you check for this. It says, all right, if user.title, then you can push, otherwise you can't. It does some analysis to make sure that you have handled the cases where stuff can just not exist. Stuff can be null or undefined or the wrong type or the wrong values. And it basically, Flow is, again, like you state your intention and it says, no, you screwed up. State the intention, tells you it's screwed up. Eventually, all thumbs and you get on with your job. I rely on this process on my day job. I don't write Java. I write JavaScript sometimes, and I switch between a bunch of different languages. Some are but overwhelming, they're all statically typed. And I have this workflow going. It's invaluable. It means I can just focus on a little piece of a problem and basically define the edges of it. I state the intention to the computer, and it keeps saying no, 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 yes. Particularly with the stronger the type system, the more likely it is when it actually finishes and compiles and says yes, or type checks and says yes, the more likely it is you've you've satisfied the intention. Like you say, I'm intending to do this, and then you've actually done that. Great. Whether it's the right thing or not is more in the realm of tests, but it's like some internal consistency. It's like double entry bookkeeping. Do a thing, they have to line up. Cool, we can move on. Okay, cool. All right, let's talk about some of the neat things you can do with it. So this might be very useful if to the Redux people in the audience, if there are any. So we've got traffic light color, where we're saying we've come up with a new type that's just shorthand for this or thing. We've got something called a type union, where it's red or it's yellow or it's green and nothing else. Not null, not orange. It's just literally these strings and nothing else. So for example, I've got good light down here, which we're saying I intend for this to be a traffic light color. Cool, totally compiles, or totally type checks, sorry. I say this and I give it purple, and it's like, no, purple is not a traffic light color. Please do it again. It basically, and if I intended for purple to be a traffic light color, I can go back to the definition. It could be several files away. It's doing this check across a whole bunch, like across your entire program. So I several files away, go back and change the definition of traffic light color to, to include purple. Cool, it checks out. Again, intention, satisfying it.
Rob?
Yep.
Can you go back a bit?
Sure.
If you uncomment that bottom line again now, it's telling us that the error is up the revenue thingies. What are they called again? These are every
strings.
Again.
Strings.
That's no. It's,
oh.
Well, the string starts with the quotation. Thank you very much.
Yes.
But when it returns it, it doesn't return the quotation with the string.
Sorry.
The errors come. The underscore under here is saying it thinks the error is there.
Yep.
But that's not the string kind of, is it?
It's saying that it's got two underscores, and this is more what my ID is telling me rather than flow specifically. But I've got two underscores. I've got one underscore here, and it's highlighting this. It's saying this type doesn't line up with this value. Basically, these things don't line up. Something's wrong here. Does that make sense?
Yeah.
Cool.
It's just us showing up on the quotation mark rather than...
Yeah. Basically, if this...
Who thinks the string is the word, not the quotation mark and the word? Just me. Okay.
Yeah. I would like to actually highlight the entire thing, and different IDE stuff do different things in terms of what they highlight or whatever. This is my NeoVim plus whatever because it's a little bit baroque. Sorry, briefly.
Does GoodLight now also type check as a string?
No, yes, you could use it in, if you could broaden it. You basically start with the very specific things, red, yellow, green, and you can broaden that to literally any string, but you can't go the other way without a bunch of if conditions and stuff, like the checking if something's there or not. It's like checking if it's a, this is, sorry, I do want to come back to that. Maybe it can be a Q&A later, but.
Have you put any in the string email?
Actually, I haven't tried this one. Rob does say no, but yeah.
Oh my goodness.
Escape hatch, you lift the lid, you put the thing in, all right. Please don't do that anymore. Blocks, none of you are free of sin. All right, so you can do other things with this union stuff. It's like string or a string, like fantastic. But I could do more structured stuff. This is, I can accept an object that has the name specifically diamonds and nothing else, and the color red, or hearts and the color red, or space, you get the idea. So you can't actually have, like, I'm gonna go const blah, and I'm gonna say it's a suit, and I'm going to go name of, say, spades. God, this is a test of the live coding thing. Please fucking work. Anyway, sorry, my intuition is correct. Anyway, so you can't have a red spade, is what I'm saying. I've set up as only that combination, which is incredibly handy. And there's an example just after this, which will show you exactly what this is useful for. But so we've got the specific things there and their objects, or we've got rank here, for example, which is like an object, or this number, or this number, or this number, or this number. And basically we're representing the ranks and we're representing the suits, and then we're going to stick them all together. We're going to compose type definitions. More on that in the next talk. We're going to compose the suit and the rank. We're going to stick them together. Say a card has a suit and a rank, and cool. All right. So the example where this is going to be useful. I have something called like a post from a server, which is representing like posts loaded remotely. And it's the status of it is either like it's loading or it's failed to load or it's succeeded. And then I've also got the list of items it brings back. And then I've got the error, which it might be a string or it might not be there. And there's a shorthand for this in both cases, I think, called like string, which is like, it might be there, but this is more explicit. So I'm saying it's either a string or a null representing no error. And so we're going to use it in here. We've got render posts, loading, failed, and succeeded, respectively. And this seems pretty all right. And so we've got stuff that seems to make sense. We've got the status of items, error, and the null. Sort of like these things kind of make sense as data. There's some redundant stuff in there, but you know, well, it's basically it's doing its job. But then we can do stuff. We can write stuff like this, and this will quite happily type check, despite the fact it makes no sense. You're failed, but you've got some items, like, and there's no error message. Like, it's not right here. Or we've got you know, status is succeeded, and we've got no items, which is valid, and we've also got an error. So it failed or it didn't. Like we've got all these like these invalid states, these combinations of stuff that doesn't make any sense. So if we can try and eliminate this as much as possible, maybe we'll get some more robust code because we can't. With the type checker will make sure we can't get a value. We can't even make a value that is wrong in this way. So let's have a look at our original type, and that's the only thing I'm going to be changing this. So let's have a look. Let's say we're going to go status loading, and that's it. There's nothing else. Doesn't make sense to have anything else in there. Or we've got status is failed, and when we do have a status, we always have an error message. We absolutely always have to have an error message. And we've got a status of succeeded, and then in this case, we always have an array of items. And the items could be blank, we don't care, but it's like, it's a list of items, and as opposed to having items you're not supposed to or whatever. It's basically this is boiling it down to the states we actually care about. So at which point, let's scroll down to our example here, the WTF example. And we've got failed and some items and null. It's like this ain't lining up. It's basically, it's wrong. So failed should, you know, should always have an error message. So that case is happy. Now, the rest of it's still garbage, so let's lock it down a bit further. We've got this thing which is like, has a field of status and has a string, but let's say we want to have only those fields on each of these definitions. It's a way of constraining it to just these fields. Cool, all right. It's having a whinge about the things that I need to fix up here. So we've got loading and items and error. Well, that doesn't make any sense, so let's just kill off that. Okay, cool. Failed, never has any items. Cool. Status, succeeded, has items, and the error thing doesn't make any difference, it doesn't make any sense, so that's gone too. Yep. We've got WTF, failed, should never have anything else except an error. Succeeded should never have an error attached to it, doesn't make any sense. And loading should never have any additional information at all because we don't really have enough info to say. Yeah. So basically what we've done is we've constrained the valid states that we can't actually, the program will not type check if we go to say, here's my post from server and it has this shape that doesn't make any sense. It doesn't match this type structure. This is where type design comes in. Where we're designing our program, we're restricting our program in particular ways using types, and the types are checking it for us. I hope I haven't lost too many people with this particular example, but I'm going to keep moving because I'm very close to, well, I'm very sorry. All right. I'm going to bail out of this one. This is a way of, I'll very briefly do part of this one. Reverse here is saying it's a function that has some x. It's something we haven't defined and can't be known by reverse itself. And it takes an array of this type x and returns an array of the same type, and only that same type. It's basically like, it's almost like, you know, how parameters to functions get filled in, like you give a 2 to a function as a first argument, and then you fill the 2 in as you're evaluating it. Like, for example, if I had a recursive string, for example, then this would become a string, and then this would become a string, and it works on that. But we don't actually need that sort of specificity. So we just want to operate on the array itself. We're deliberately ignoring the possibility of what the hell is inside this array. X is deliberately ignored, and we end up with safer functions because it can do less on the stuff you're giving it, except you basically say, I don't care about this, so I'm going to prevent myself from doing anything with this. The only thing I can do is I can only like delete items, I can only move the items around, I can only duplicate the items. I can't invent new ones because I don't know what the valid value would be that satisfies the type. We've got an array of strings. Like, I don't know if this is strings or numbers or an object or a class. I can't make any new things. And so reverse can do less. It is now safer, it is more predictable. And with that, I definitely am going to jump back to the Prezo to wrap this up. But very briefly, this is slightly more real world and is simple, and I will lock it off just after this. So we've got a React component, we've got props, and if people have seen prop types, which defines the inputs to a component, this is basically saying the types of things instead. We use types instead of the prop types. And it's a compile time check. It's something you do before you even run the code, and it checks a bunch of the stuff for you. So I'm going to go and add a color to this component, and add the color up here, go and use the color, and immediately it'll say a bunch of stuff broke. This is stuff across the other side of the code base. This is a component, now it's saying a bunch of pages are broken. Cool, let's go to the pages, let's go and fix them one by one. Tells me it's good. And this particular bit of workflow is entirely what I rely on work. This workflow, change something here, have all the broken things show up in a list, is invaluable. It's the sole reason I'd be using a tool like this. Anyway, definitely wrapping it up. Contain your mistakes. Write down your intent with type signatures to clarify the intent. Tell the computer what you mean. And design your types. Try to use the types to exclude errors from even existing. Hi, I'm Rob, and thank you very much for your patience. Sorry.
He went, oh, no balance and symmetry. Hang on. I'm missing somebody. Where's my Justin? Could you be further away? Come a bit closer. I had a good thing, but I can't say it. Do you have any questions for Rob? I'll take two. No? Yes.
You mentioned just a little bit earlier that both Flow and TypeScript were relatively on par. How might you sort of compare the type inference between the two?
TypeScript 2 changed in a bunch of ways. The inference for Flow, like Flow can figure out more stuff for you than TypeScript, but it's very close now. Basically, every time I look at TypeScript, it gets better, and then I go and look back at Flow, and it gets better, and like, oh Christ, can JavaScript stop being JavaScript for 10 minutes and let me catch up? Because, you know, it's annoying. So basically, TypeScript is, I think, lagging behind in inference, but otherwise they're mostly the same, and they keep beating each other and then falling behind. It's frustrating. Sorry. There's a second question?
I mean, on par with that, if you had to pick for a hypothetical greenfield project, TypeScript or Flow,
that's fine.
hypothetically, what would you do?
I would choose Flow if only. I choose Flow specifically because of one feature. You can say something with Flow that you cannot say with TypeScript. TypeScript is only thinking about the structure of things. Flow lets you think about structure, like have structures that are the same, like you've got a field that is the same as a string and it's matching. Sorry. Basically, I can name something in Flow and have it never conflict with literally anything in any other code base at all. TypeScript doesn't let me do that. TypeScript means it doesn't give me the power to actually to come up with something which is unique, and once I create it, cannot be confused with anything else. I realize it's incredibly fucking vague if you're not deep enough into this, and that's basically the sole reason, because I do a bunch of stuff in Haskell and PureScript and things that rely on these name types to be airtight. I prefer that the more airtight the thing, the more I prefer it, and so my perspective is that Flow stuff because of it, and this doesn't make any sense. I'm sorry, you?
Are you saying that like the types don't have scope in types?
No, they have scope. You can import them in. It's just a case of you import foo and it has a field name that's a string, and you import bar that has a name that's string. You can confuse them. It's like, whoa, I've got something with an X and a Y and they're both numbers, that I can confuse them. I've got something that has a number that's a temperature, and I've got a number and it's got like a field, like if I've got a temperature which has a value in it, which is a number, and I've got a length which has a value in it, which is a number, I can confuse the two. I go class temperature and it can be confused with class length or whatever.
So you declare something to be a temperature, which is a number, and then you can't pretend that it's a different number.
Yeah, I would pull up examples on the board because it's a little hard to show with the textually. But hey, I'll hang around outside after the. Anyway, I'm sorry. We're gonna wrap this up.
Can we thank Rob again, please?